I'm told that the limit of some function as x approaches 2 is 7, and I'm told that the limit of g of x as x approaches 2 is 3. It asks me to find the limit of f of x times g of x. Well, keep in mind, I can break up a product of limits. That's just going to be the limit as x approaches 2 of f of x times the limit as x approaches 2 of function g. And they give me those values, okay? They tell me this limit is 7. They tell me that this other limit is 3. Those are being multiplied together. My final limit's 21. So don't make this harder than you need to make them. As long as you have the function value, it doesn't matter if you have the original function. Let's see if I've got another one here. Okay, another one, limit as x approaches 2 of 4 times f of x. Well, I know I can divide out that constant. That's going to be 4 times, well, actually, yeah, that's going to be 4 times the limit as x approaches 2 of f of x. And same kind of thing here. I know the limit as x approaches 2 is 7. 4 times 7 is just equal to 28. So you will see some cases where you have to apply those limit rules. Okay, last one here. Limit as x approaches 2 of g of x plus 2. So again, that's going to be the limit as x approaches 2 of function g plus the limit of the sum, the limit as x approaches 2 of 2. Notice that that's a constant, so I know that g's value is 3. I know that the limit as x approaches 2 of the constant is going to be 2, and that function limit ends up being 5. So keep those rules in mind. Very easy to work with. Okay, next example, right and left-hand limits. In this case, the function is the limit as x approaches 4 from the left-hand side, okay, coming from the negative side of the graph of the function 2 over x minus 4, quantity x minus 4. And if you notice, if you put 4 in here, you get a 0 denominator. So I really need to take a look at my graphing calculator and see what that graph is going to look like. And very quickly, as you make a graph here, what's going to happen is at 4, there's an asymptote. The graph is going like this on one side, and the graph is going like this on the other side. So as it approaches 4, from the negative side, from the left-hand side, we can see that the graph is going downward infinitely. We get a limit of negative infinity. Okay. The next limit here is the limit as x approaches infinity. Once again, if you graph this on your graphing calculator, you can actually substitute in very large values of x, and you're going to be able to see your solutions here. You can also look at the graph. As x gets bigger and bigger and bigger and bigger, you can see that this graph looks like it gets closer and closer and closer to the x-axis, and that in fact is the case. It's going to get closer and closer and closer to a functional value, a y value of 0. So for that last case, this thing is approaching 0. For my final problem, I'm going to look at an example of the Intermediate Value Theorem. I'm given this function, x squared minus 4x plus 7. I want to find the value of x in the interval from 4 to 7, guaranteed by the Intermediate Value Theorem such that y equals 10. It says to round to the nearest thousandth. I'll let you take care of that on your own. But here's the key idea. Intermediate Value Theorem says that if the function is continuous, and that's very important, if there's a jump in the function, this doesn't apply. But if the function is continuous, and this is a polynomial, so it is continuous, if I have two values of the function over some interval, let's say that the function is equal to 10 at some value of x, and it's equal to 6 at some value for x, I know that that function has to pass through any values between 10 and 6. So the function has to pass through 8 somewhere, it has to pass through 7, it has to pass through 7.3. And so you'll notice here, you don't necessarily have to do it for this problem, but if I found f of 4 in this problem is going to be equal to 7. If I find f of 7 in this problem, it's going to be equal to 28. somewhere between x equals 4 and x equals 7, this graph has to pass through all possible functional values, all possible y values between 7 and 28. Okay, and you'll notice here 10 definitely is between 7 and 28. So I know that somewhere on this graph there has to be a point in that interval between 4 and 7 that passes through a value that gives you y equals 10. Okay, so very easy way to do this. I'm just going to set the function equal to 10. I know I'm guaranteed a value. X minus 4x plus 7 is equal to 10. I want to solve for x that'll find this in that interval. Subtract 10 from both sides. I get x squared minus 4x minus 3 equals 0. I thought this was going to factor, but I would need a -3 and a -1 to get a -4, and that'll give me a +3 there. So I'm going to have to use the quadratic formula. A is going to be 1, B is going to be -4, C is going to be -3. X equals -b plus or minus the square root of b squared minus 4ac. -4 times 1 times -3 is 12, all over 2 times a. And if I simplify this, that's going to be 4 plus or minus, this is radical 28, which is 2 radical 7, all over 2. I can simplify this down, that's going to be 2 plus or minus radical 7. Okay? I believe if you take 2 minus radical 7, you're going to get a value of x that's not between 4 and 7. I'll run the numbers on this, we'll see what happens. Meanwhile, 2 plus radical 7 is going to work out to be approximately, it says nearest thousandth here, so 4.646, rounding, it's actually 6457, but rounds to 6 to the nearest thousandth place. And that is my value of x between 4 and 7, guarantees me that I get a y value of 10.